Hello, my name is Caitlin Pace, and today I will be talking about L'Hôpital. L'Hôpital published a book titled Analyse des Enfants Petits. This book was translated into English by Eastone. The title of this translation is titled The Method of Fluxions, both direct and inverse. But before I start discussing this book, I must discuss the relationship L'Hôpital had with John Bernoulli. John Bernoulli was a pretty good mathematician, but he had only published one paper at the time he had met L'Hôpital. L'Hôpital knew he was good, so he asked Bernoulli to teach him calculus. Bernoulli taught L'Hôpital calculus for about a year. Later, L'Hôpital presented an offer to Bernoulli. L'Hôpital offered to pay Bernoulli for his mathematical works if he did not publish his own works. L'Hôpital also promised not to publish any of Bernoulli's works and claim the glory for himself. Bernoulli did not have much money at the time, so he agreed to the proposal. But L'Hôpital did not keep his promise. He mailed a mathematician a solution to a problem that previously had no solution. L'Hôpital did not claim the solution as his own, but he also did not inform the reader that it was not his. So the receiver assumed the sender was the one who had come up with the solution. When Bernoulli heard, he was upset. L'Hôpital wrote him a letter apologizing, saying no more work would be seen from him, and then flattered Bernoulli by writing that, and I quote, "I am very sure there is scarcely a geometer in the world who can be compared to you." Bernoulli accepted the apology and the compliment and moved on. However, this peace did not last long. Soon after they made up, L'Hôpital published his work Analyse des Enfants Petits. Technically, he did not break his promise because he did not put his name on the book. But this didn't matter to Bernoulli. At first, Bernoulli wasn't really all too upset. But after L'Hôpital passed away, he started becoming more adamant that people recognized that L'Hôpital's work was actually his work. Most people did not believe him because he had waited so long to make a fuss about it. And after the person he was accusing was already dead and could not defend himself, it just seemed pretty sketch to everyone. This late claim to his work may have been brought on by the fact that L'Hôpital's book had become a popular teaching tool for calculus. Within the preface of L'Hôpital's book, Bernoulli did receive a little bit of credit, but he also gave a little bit of credit to a lot of other people, such as the ancients. He literally said, the ancients. And he calls Archimedes out by name as one of the people who helped set up the foundation for calculus, even though they didn't actually really discover calculus. And then L'Hôpital also mentions that the great Sir Isaac Newton was the one who really discovered calculus, and that Leibniz didn't really discover calculus. He just merely created an easier to understand notation. I find this pretty funny because Leibniz was one of the few people who actually did believe Bernoulli, and that L'Hôpital didn't actually write Analyse. Well, he did write it, but it wasn't his information. Now I will discuss the actual mathematical content of Analyse. In section 1, the terminology is a bit different than modern calculus terminology. For example, what L'Hôpital calls a fluxion of a function is known today as the derivative of a function. L'Hôpital also presents two postulates that he considers to be undeniable truths. Postulate 1 declares that there is a space between 2 points that can increase or decrease by an amount so infinitely small it appears to not have changed at all. Postulate 2 is about how a curved line is made up of many small straight lines. He compares this layout of the lines to a polygon with an infinite number of sides. L'Hôpital really likes this comparison and uses it throughout the book. L'Hôpital also discusses the product and quotient rule within the first section of his book. The product rule is, of course, the derivative of x times y is equal to x times the derivative of y plus the derivative of x times y. And the quotient rule is, of course, the derivative of x divided by y is equal to y times the derivative of x minus the derivative of y times x all over y squared. After he explains both of these rules, he then decides to explain how to derive x with an exponent. I find this odd not only because I was taught this information in a different order, but because you also need to know how to derive x with exponents to use both the product and quotient rule. One thing that makes L'Hôpital's book so messy to the modern reader is the fact that L'Hôpital does not use the chain rule. I believe he did not know the chain rule, because he never introduced it, and had he known about it, it would have made his life so much easier and saved himself so much extra work. But I also can't really know for sure because after section 1, he pretty much doesn't show any of the steps between the function and the derivative. He simply says, here's the function and there's the derivative, and then moves on. In section 2, L'Hopital discusses tangents. Tangents are straight lines that touch curves at one point, and at that single point, both the curved line and the straight line increase and decrease at the same rate. In section 3, L'Hopital discusses maximums and minimums. L'Hopital says that a maximum or a minimum occur at the point in which the derivative equals 0. However, what I find odd is the fact that L'Hopital never really explains how to tell the difference between a maximum and a minimum by just looking at the function of the derivative. Today, we could tell the difference between a maximum and a minimum by if the derivative is above or below the x-axis before or after the point in which the derivative equals 0. If the derivative is above the x-axis before the point and below the x-axis after the point is a maximum on the original function, and if the derivative is below the x-axis before the point and above the x-axis after the point is a minimum on the original function. He may not have said this because he did not actually use axes. Instead, he used perpendicular lines that were not identified as the x and y axis. In section 4, L'Hopital discusses points of inflection and points of retrogression. He first defines what a second derivative is, and as anyone who has taken Calculus 1 knows, the second derivative of a function is the derivative of the derivative. He, of course, defines the point of inflection and retrogression as the point in which the second derivative equals 0. And then finally, after all this time, L'Hopital decides to clarify his notation. Fortunately for me, the translator had decided to explain L'Hopital's translation after the preface but before section 1. If I had been reading the original French version and not known calculus beforehand, I would have been very confused throughout the entire book thinking, okay, so why do some of these x's have dots over them and some of them don't? Oh well, whatever, it must be a mistake, right? But really, in L'Hopital's notation, an x with no dot over it is the original function, and an x with one dot over it is the first derivative, and an x with two dots over it stands for the second derivative. L'Hopital's absent-mindedness about how a new student can be confused by certain things and introducing information in a not-so-practical/logical order are my biggest issues with this book. For example, his first example he gives in section 4 is very complicated and takes a lot of skill to derive in the first place, especially twice. So I don't understand why he couldn't just start with a simple function and so simple example and then move on to the harder examples. Anyways, now I'm going to skip a few sections to section 9. Why section 9? Because that is where L'Hopital's famous rule is explained, or should I just say written. Today this rule is known as L'Hopital's rule, but of course he did not name it after himself because he did not even put his name on the first several editions of this book, and as usual, other people name rules after the people they believe to be the creator of the rule. But as we all know now, Bernoulli is the actual creator of this rule. Anyways, L'Hopital's rule is applied to find the derivative of indeterminate forms, such as when equations are equal to 0 over 0 or infinity over infinity. And according to the rule, when this form appears, to find the derivative of the function, you take the derivative of the numerator over the derivative of the denominator, and that is the derivative of the indeterminate function. Although the rule is applied to both indeterminate forms today, 0 over 0 and infinity over infinity, the only indeterminate form that is mentioned within L'Hopital's book is 0 over 0. Well, that's all I have for today. Thank you for your attention, and if you have any questions, feel free to ask.